Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving deep into the fascinating world of exception handling in the JVM. We're currently in Level 3 of our series, exploring JVM expert topics specifically focusing on JVM internals. Joining me as always is our JVM guru, Victor. Are you ready to unravel the mysteries of exception handling, Victor?
Absolutely, Sheila. I'm excited to explore this crucial aspect of JVM internals with our listeners. Exception handling is a fundamental part of writing robust Java applications, and understanding how it works under the hood can really elevate a developer's skills.
Couldn't agree more. Before we dive in, let's set the stage for our listeners. To get the most out of this episode, you should be familiar with basic Java syntax, including try-catch blocks, and have a general understanding of JVM architecture. Now let's kick things off with a brain teaser for our audience. Victor, would you like to do the honors?
Sure thing, Sheila. Here's a question to ponder. In a Java program, if an exception is thrown in a try block, and that exception is not caught by any catch block, what happens to the finally block? Does it still execute, or is it skipped entirely? Think about it, and we'll reveal the answer at the end of our episode.
Ooh, that's a tricky one. I'm sure our listeners will be mulling that over. Now let's start with the basics. Victor, could you give us a quick overview of what exceptions are in Java?
Certainly, Sheila. In Java, exceptions are like alarms that go off when something unexpected happens in your program. They're used to handle errors gracefully, preventing your program from crashing abruptly. Java organizes these exceptions in a family tree, with a class called throwable at the top, and then branches out into error and exception categories.
That's a great starting point. Now, I understand that exceptions are broadly categorized into checked and unchecked exceptions. Could you explain the difference and how the JVM treats them differently?
Absolutely. Think of checked exceptions as planned fire drills. The compiler insists you have a plan for them. You either need to catch them or declare that your method might throw them. Unchecked exceptions, on the other hand, are like unexpected fire alarms. The compiler doesn't force you to plan for them. From the JVM's perspective, the main difference is in how it verifies these exceptions during the class loading process.
That's a helpful analogy, Victor. So, when an exception occurs, what exactly happens inside the JVM? I've heard the term stack unwinding being used. Could you explain that process?
Great question, Sheila. When an exception is thrown, the JVM initiates a process called stack unwinding. It's like a safety net in a circus act. Imagine an acrobat falling, and the circus crew quickly moving the safety net up through different levels to catch them. Similarly, the JVM searches up the call stack for an appropriate exception handler, catch block. If it finds one, execution transfers to that handler. If no handler is found, the thread terminates.
That's a vivid analogy, Victor. It really helps visualize the process. Now, I'm curious about the performance implications. Does this constant checking for exceptions impact program execution speed?
You're touching on an important point, Sheila. The exception handling mechanism does have some overhead, but it's generally negligible in normal operation. The JVM uses exception tables, which are like quick reference guides that map specific code regions to exception handlers. These tables allow for quick handler lookup without significant runtime cost. However, actually throwing an exception is relatively expensive due to the stack unwinding process and the creation of the exception object.
That makes sense. So, it's not the try-catch blocks themselves that slow things down, but rather when exceptions are actually thrown. Speaking of which, how does the JVM handle exceptions in multi-threaded environments? Are there any special considerations?
Excellent question. In multi-threaded environments, where multiple parts of a program run simultaneously, each thread has its own execution stack. So, exception handling is generally thread local, meaning it's handled separately for each thread. However, there are some interesting scenarios to consider. For instance, if an uncaught exception occurs in a thread, it doesn't necessarily crash the entire application. Instead, the JVM calls the thread's uncaught exception handler, which can be customized to perform cleanup or logging operations.
Fascinating. It seems like there's a lot of flexibility built into the system. Now, let's talk about best practices. What are some common pitfalls developers should avoid when working with exceptions?
One major pitfall is catching exceptions too broadly, like catching all exceptions at once. This can mask important issues and make debugging difficult. Another is the overuse of checked exceptions, which can lead to cluttered code. It's also crucial to avoid swallowing exceptions, that is, catching them and doing nothing, which can hide serious problems.
Those are great points, Victor. To wrap up our discussion, could you share any recent developments or future directions in exception handling for the JVM?
Certainly, one exciting development is the introduction of more precise rethrow in Java 7, which allows for more fine-grained exception handling. Looking ahead, there's ongoing discussion in the Java community about potentially unifying checked and unchecked exceptions, which could significantly change how we think about exception handling in Java.
That's really exciting. Before we conclude, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course, the answer is that the finally block will still execute, even if an exception is not caught by any catch block. This is a key feature of Java's exception handling mechanism. The finally block always executes, whether an exception is thrown or not, unless the JVM exits or the thread is interrupted.
Thank you, Victor. That wraps up our deep dive into exception handling in the JVM. To summarize the key points. 1. Exceptions are objects representing unexpected events in Java. 2. The JVM uses stack unwinding to find appropriate exception handlers. 3. Exception tables are used for efficient handler lookup. 4. While try-catch blocks have minimal overhead, throwing exceptions can be costly. 5. In multi-threaded environments, exception handling is generally thread local. 6. Best practices include avoiding broad catches and not ignoring exceptions. In our next episode, we'll be exploring JVM languages like Kotlin, Scala, and Clojure. Don't miss it. If you've enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue creating in-depth content about the Java virtual machine. Until next time, happy coding.